Hello. 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 Hey, everyone. Thanks for coming. So I think it's awesome that people are coming and speaking in English that isn't their first language. I just gave my first presentation in German the other day, and it was really, really horrible. So these guys are doing a great job. You guys are all listening in English. I feel really lucky. It's my first language, and I get to just talk it at everyone, and they understand what I'm saying. That's awesome. I think awesome. Thank you. But maybe to get me back a little bit, I can't say the name of this town. I have a really, I feel like there's a vowel that I can't get around. Yeah, but I mean, I need help. Someone. Bruno. Is that right? Yeah. Kind of. It's all right. It's good. Okay. So this is that's some stuff happening there. So this is me. I'm Aaron. I'm the other bearded bald guy that's talking tonight. This is what I do for a living. Speaking of the speaking here, just a tip, if you guys ever want to speak at another meetup, don't tell Jan about any kind of sickness that you might have, because... So I do this. I build prototypes and beta stuff for startups and try and help them find funding. I do these kinds of things. So if you want to look in the opposite direction of Go, for the simplicity, if you want to go to the other extreme of complexity, you should check out Swift. I'm really starting to really, really like it, but it's huge, and you could probably build Facebook Messenger just using the enum type in Swift. It's really, really crazy, but the language actually keeps getting, I feel like it's getting better, and they're doing things to kind of make it's interesting. Check it out. And it's going to start, they have web servers, like Nginx kinds of web servers that are built in Swift now, and they're talking maybe about Android being in Swift instead of... So I organize Golang Vienna. It's really new. We're having our second meetup actually tomorrow night. I'm really bad at organizing meetups, so I think there will probably be 6 people there, which is different than what happened here tonight. So great job, organizers. Is it plural? Whatever. Good job. Fantastic. So Go has a lot of things in common with object-oriented programming languages. So if you're coming from a lot of the languages where people came from, the question was asked, Ruby developers, how many Ruby developers are there here? There was 3 hours. So there's actually going to be Ruby code. I might skip over it. I was thinking about just removing it. But the first or maybe the second time I was speaking in front of a lot of people interested in Go, I think that 90% of them were Ruby developers. So I'm like, oh, maybe Ruby's a good example. And now there's hey, Ruby guys, what's up? So maybe we'll skip over it. It might not be important. So if you're coming from Ruby, Java, Python, lots of Python people, there's a lot that you can kind of be comfortable with Go. So some things that there are in common is what was talked about is the uppercase and lowercase encapsulation. So things are kind of private if they're lowercase to a package, and they're not if they're uppercase. There's kind of a this and self sort of situation. It's really similar to Python if you have a struct that has methods, you kind of you give your this as an argument before the name of the method. You'll see that probably in a bit. Your structs have constructors, kind of. There are methods on structs, and there are mix-ins, you can embed a struct inside of a struct. It's kind of an Inception sort of style going on. And there are interfaces, which I will be kind of talking a bit, but in the context of duck typing. So duck typing was talked about a little bit. Duck typing was the first time it was kind of, I guess, talked about was in a mail a mail list message from Dave Thomas, who is an interesting fella, and he was trying to kind of say what the difference is between how in Ruby you do duck typing, or how you do send messages around, and how you would do it in something like C++ or Java. So duck typing, it just means, like we said earlier, if it walks like a duck and it quacks like a duck, then it's a duck. And it's really about sending messages back and forth to different kinds of objects. Are they called? That's my hard thing with Go. instances, or?
There are no objects. They are just values of certain.
So it's just would I call it an instance? If I created a struct, would I say this is an instance of a struct, or would I say this is a property, a member of the global world?
There are no classes, right?
Yeah.
So you just have types and values.
Okay. So messages. So and when you're sending messages, when you're dealing with duck typing, you don't care about kind of what something is, but you care about what it does. You care about its behavior more. And some benefits that you get from duck typing are it makes testing easier in some cases where you can, if you have an interface instead of using actual structs and things, you can mock things like HTTP servers and things much simpler. You have these public interfaces that are clearly defined, which was mentioned about Python, where you felt that Python is kind of missing interfaces sometimes. I feel like that with Ruby as well. Sometimes I kind of just want I want to be able to say this thing is this. And instead I do the way that I do statically type stuff in Ruby is by my comments tell me what the type is, which is total crap. It's an awful way to do things. But so it gives you these. It makes it so you can kind of, if your interfaces define your code that changes the least, then it's easier to kind of change other code around them. And then you can rely on these public interfaces, and then the rest of your code you can kind of go insane with and be crazy. So Avdi Grimm, who is a member of the Ruby community, he kind of coined the term confident code. And confident code is code that it kind of has a narrative. There's input, and then there's work done, and then there's output. It kind of tells a story. It's not I don't know what I'm doing where. It has a purpose. And tell don't ask is kind of one of the premises of it. And tell don't ask is kind of like, I'm not going to say, hey duck, like what are you a duck? Like what are you? Instead I just say, hey duck, quack. Just do it. Just quack. And then I don't care. Then I just move on to the next problem. So here's my Ruby code example. I don't know if I really need it, is the thing, because then I kind of do a Go code example after it. Let's see. I'm just going to do it. So pretend this is pseudocode. It's not Ruby. It's pseudocode. And if you're using JavaScript or Java or something, def is like function. But besides that, it's pretty okay. So what we have here, I don't know if it's actually possible for anyone anywhere back there to read this. The other code examples are bigger. So this, my fake world, I'm creating something that prepares different things for download, different documents for download. So this, if I'm creating a PDF, I need to turn the first page into an image. I need to optimize the images inside of it for a PNG, and I found that no one actually calls these pings. Does anyone call this a ping here? I think they're actually supposed to be called pings, but no one calls them pings. Maybe I'm going to have different sizes of my PNGs. And I started calling them ping. I'm kind of upset because I started calling them pings because I think Wikipedia told me to say it. And then a text file, maybe I zip it before I download it. So in my fake object-oriented programming language, I would create these different things like this using new, which most people are familiar with. I create a list, an array, a something out of them. And then I can iterate through them like a for, say this is a for, and ask it what it is. And I say, hey, are you a PDF? If you're a PDF, then I will do these things. And then if you're a PNG, I will do these things. Text file, I'll do these things. So we kind of want to pull the ducks out of this. So we are going to, on each of our classes, we're going to create a prepare download method. And our prepare download method takes care of all the other stuff. Then we can just get our documents. We know that they kind of implement this interface, which are programming language, our pseudocode programming language that may or may not be Ruby. It doesn't really care. It just says, OK, I will prepare the downloads and explode probably if it can. And then with Ruby or whatever this fake language is, there's a one-liner. Woo, one-liners. So go time. I'm just going to read off the slides now. Here, this is an example of our first crappy example where we're creating structs. This one is, let's say our PDF has a body. It's a byte slice, so it's just bytes. We have our different versions in the PNG style. Our body is a string in the text file. We create our methods on each of these things. They're pretty much the same as in the other example. And then this is what we would do. We'd create a slice, so like a list of this interface type that we don't have to care about at all right now at the moment. It's not important for the example. And then we range the things, and we do the same thing we did with the pseudocode. We say, is this a this? Okay, then we'll run these things on it. And the thing is that this is that's complete crap. So we're gonna pull the ducks out for our Go code. So we create this interface at the top. That's the download prepare interface with a nice prepare method, and then we just have these prepare methods on everything, and we implicitly implement these interfaces. So here we just create our download preparers now, and then we call prepare on them, and that's how beautiful our code gets. Our statically type checked code in our Go. And our ducks are beautiful. We just have lots of beautiful ducks happening. And so the last time, kind of when I first gave a version of this talk, I found out a couple days before the talk that the other person who was giving the talk, or another person that was giving the talk, was giving an interface talk. I said that really weird. And it turns out that he was giving his talk before me at 2 different conferences. So they're like, hey, guy, your interface talk, there's another interface talk. So I just went crazy off into the duck direction, and that's why there's lots of ducks. But now I'm going to talk just about kind of interfaces for a second. So the standard library, as was said earlier, has some really good examples of interfaces and how to use them and why you would want to use them. One of my favorites is sort.interface. It's part of the sort package. And let's give a little bit of example. I'm actually going to use this thing now. I like to pander a little bit to my audience, and I try to get really Czech-looking street names here. So we have this, say we're a real estate agency. We have homes, and we are here. We're creating a home slice. Wow, I didn't even mean to do that. That's kind of American slang. It's good stuff. And then we are appending these homes that we're creating onto the end of it. And then we're just printing the buyer name, the person who's buying the house. So what this will do is it will just print Bob Boberson, Alice Jones, and Timmy Johnson. It'll just print out their names. So what we want to do is we want to sort those names. And one way that you can do that in Go is using the sort.interface. So to use the sort interface, you have to implement these 3 methods. And one of them tells you the length of whatever the list that you have is. One tells you how you swap the values, and the other one is essentially like what you normally see in a sort function, that one thing is greater than another thing, and like in JavaScript, probably in Java, you have something really similar. So what we do is we create this new type. I'm not good at using this thing. It's really big on the screen. I don't even need to point at it. And it's a type that is a slice of homes. And then we just add this. So this is what I meant by method with the self. So this would be like self, or this in Java, or self in Ruby, or Java. No, Python. Python is what I meant. And this is us actually doing it. So our by name, so that's our actual slice. By name, not by name. That sounded weird. You get the length of it. And then this is just swapping the value, super simple. And then this right here is an example of kind of like this thing. This name is less than, so like A would be less than B. And then we do this sorty thing here, and then we coerce the by name, the homes, into a by name, and then we print stuff out, and we get our people. It's amazing. It's really, really amazing. It's sorting. Sorting is cool. So HTTPHandler is another one. Go's HTTP library from the standard library, the HTTP package, is pretty awesome. Like this is essentially, there's like maybe an import statement and like a package statement at the top, but this is an HTTP server, because I think that's one thing that people get really excited about with Python, is that I can make an HTTP server in 1 line of code. But like this is building one in Go. So a lot of people don't even like use outside packages to do basic HTTP servers and things, because you can get so much value out of the standard library. So this is how you would normally create a handler. So you have this handle func. This will be the base URL, the path, and then this is the function, blah, blah, blah. And then your functions are HTTPHandler func is what the type is. They take a HTTP response writer and the thing. What is this guy? This pointer to an HTTP request, and then you write into that guy, and then you get this really awesome homepage. So thank you. And then what you can also do is instead of doing just that basic function, you can kind of create a handler out of any struct, and you can do that using the HTTP handler interface. And to satisfy that, you just need this HTTP, or you need the serve HTTP, and it just takes the same thing as the handler func. And what we want to do is we want to add a little bit of some state to our requests. So we're creating a counter because we want to know how many people have hit our site. It's a tool that you'll reach for a lot. So here is we're creating our serve HTTP method on our counter struct. We're upping the count here. We're setting a header in our response that shows the count as of now, and then we are printing. We're doing our awesome homepage again. So it's going to look a lot like the last homepage. So we just create our new counter. Instead of using handle func, we use handle and give it our guy here, and then we get. I'm just using this pointer a lot. This arrow isn't normally part of curl, and I get this x view count 7 because I've done it 7 times. It's not the first time. So I want to look at some places, or actually one example of a library that's kind of a cool library. It's pretty useful. That where interfaces are being used, kind of so you can see an example of how people actually use them in the real world, besides just the people that are like down hardcore coding on Go itself. Something that I really think that people should do, I think this is what my meetup will be tomorrow essentially, because there's only like 8 people, is I think we're going to do some code spelunking on GitHub. And I really highly recommend to go to GitHub, go to Explore, pick your language, and just read through some of the top repos that you see. Go through the code, maybe clone it locally so you can get through it a little bit easier, because it gets a little bit when you're trying to find where things are defined on GitHub. You get pretty far with it actually. There's even a fuzzy file finder that you can do if you press R or something. It's crazy. GitHub's crazy. So read it. Do it in your spare time. Instead of watching a show, sit down and read some source code for a crazy HTTP server, whatever. Awesome. So, and that's how I found this this S library. So what S is something where it's a command line tool where you type S, and then -P for whatever the provider is. I think it defaults to Google, which is a huge surprise. And then you can do Amazon, Reddit. There's I think probably 100 different things now. And this is searching Amazon for Gopher doll. And this is what you get. So Amazon may not work out, but the tool itself is pretty cool. So they have this provider interface that has a method, only one method, like he was saying earlier with the small interfaces. There's one method in this one. It takes a string and it returns a string. And so each of the providers, each of the Google, YouTube, Reddit, all of the things have this, implement this interface implicitly. So here we have Bing, which is a popular one, I think, to be used. And where's happening? Build URI, you can see down here, they're implementing it. And it's just making a Bing library. It's really super simple, but each of the things has this build URI. And then when it calls a search, it actually calls the build URI with the search query to get the URL, and then it launches your browser with that. So if you search for this is kind of, I was thinking about actually showing this video because it's one of my favorite videos. You'll find this Go versus, you see I've watched it before. I've watched it maybe 50 times. And it's a little rap. I think it's 1 minute long, and it's about Go. And it's really, it's good stuff. It's good. You should definitely check it out. So code confidently, create these neat abstractions. like try and pull ducks when you need them. If you're going through things and you're saying what is this? Check the type of this thing. What is this? You're probably doing something wrong. You should think about maybe delegating out to some other kind of thing. Read source code. Do that. I already said a bunch on it. I'm not going to say it again. And yeah, thank you. And if you want to see the slides, or if you want to see the video of that I just showed you without having to actually Google for it yourself, or Bing for it yourself. And oh yeah, so that's the end of my talk. Thank you. If you have any questions for me, like come and find me and ask me questions. But what I wanted to do was ask the others. Okay, so who here uses Go really regularly? There's got to be a few. So what I'm going to do is, I think the biggest question that I get asked from people new to Go, people interested in Go, is what should I use Go for? Like, I have no idea why I would use this. Like, it seems cool, it's interesting, but like, what are some use cases for it? So I kind of wanted to ask around to people who are actually using it a lot, what they're using it for. So I almost pointed to you with the laser, and that's a bad idea. What do you use Go for?
HTTP servers.
So
Server applications which can handle multiple users or do a lot of things at parallel.
okay, so is it like microservices? Are you rendering HTML, or are you doing JSON servers? What are they?
We stream videos.
Okay, so video streaming servers that need to be highly parallel. Okay, cool. And who else in here? I saw, no one? No one here? Here? You.
Basically, we are building the API, that meaning that there's a HTTP server, some REST framework, and we are doing basically the crazy stuff in the backend, like transforming the SQL queries, the rest of stuff. But by the way, you can use the Go for everything. There's no questions for what mesh to use it. Just use it.
Okay, so you're using it for people that couldn't hear it. You're using it you have like a Rail. You said Rails app?
No.
Okay.
It's basically there is some front end. Built with React, for example.
Okay.
But the meaning of the API is that it's open API.
Okay, so it's like a single page app that then is communicating with your Go back-endy sort of stuff. Okay.
The meaning is that there are some basic microservices.
Okay, so you're doing hardcore stuff on the back end with the Go. Cool. Platform as a service. Platform as a service. Okay, all right.
Actually, it's good to mention that a lot of big projects using Go, Docker, Kubernetes, OpenShift, is all building Go. Like a lot of databases also, like time series databases.
Yeah.
Monitoring.
InfluxDB.
Yeah.
Anyone else want to share what you like to use Go for? No one? I don't see any other hands. So I use it. I like to use it for command line tools and also kind of microservice-y stuff. But yeah, cool. So that's all that I. Oh yeah. I just want to do animations again. Okay, we're done. Cool. All right. Thank you.